dugsiga boardingka iyo maalinlaha ah ee Amano boarding and day school.
Alhamdulillah rabbil alamin, salatu wassalamu ala rasulillah, amma ba'du. Assalamu alaikum warahmatullahi wabarakatuh. Physics form 4, we started lesson 5, so we continue our chapter radioactivity. Okay, we started number 2, effects in electric field and magnetic field. Effects in electric field, effect in electric field in alpha, beta and gamma. How electric field affects alpha and how it affects beta and also gamma. Okay, remember that we have a now we have a source of radiation. Source of radiation. This source radiates alpha, beta and also gamma. Okay, here we have a negative plate and also we have a positive plate. So remember that positive charges attracts negative charge. Positive charges attracts negative charge. So negative plate attracts alpha particle. Negative plate attracts alpha particle. That's why alpha particle has positive charge. Also, a positive plate attracts a beta particle. So the charge of a beta particle is a negative. The charge of beta particle is a negative. Okay, but the beta is undeflected because of it has no charge. It has no charge. Alpha particle is undeflected because of it has no charge. Okay, and alpha particle is deflected less because it has a greater mass. While beta particle is deflected more because it has a less mass. Okay, so alpha is attracted towards the negative plate because it has a positive charge. Beta is attracted towards the positive plate because it has a negative charge. Okay, gamma is not deflected because it has a no charge. Okay, and number B, effect in magnetic field in alpha, beta and gamma. Effect in magnetic field alpha, beta and gamma. Okay, we have a source of alpha. Okay, we have a source of alpha, beta and also gamma. We have a source of alpha, beta and gamma. Okay, also we have a magnetic field into the page. We have a magnetic field into the page. Okay, this is a magnetic field. So virus the gamma, it has no charge and it is undeflected. So it is undeflected. So gamma, that's a gamma. Gamma is undeflected inside the magnetic field and electric field, but beta and alpha is reflected by the magnetic field. How can we determine this is a alpha or this is a beta? We can determine Fleming's left hand rule. So thumb point is direction of motion or direction it bends. Okay, first finger points as direction of magnetic field and the third finger shows us direction of current. So now we have a beta particle. That's a beta particle. Okay, so current, so electron is flowing in this direction. Remember, electron is flowing this direction. Okay, we have a magnetic field into the page. Okay, we have a magnetic field into the page and also current, electron is flowing this direction. Also current is flowing that direction. So beta, bend this down. Okay, so this is a beta. Alpha, so a positive, it's a positive charge. So current is flowing this direction. Okay, point is the magnetic field into the page. Okay, where's the current? Current is flowing this direction. Where it bends upward. It deflects upward. Okay, so direction of direction can be determined. Fleming's lefty hand rule. Okay, beta is reflected more while alpha is reflected less because beta is lighter than alpha. It means it less mass than alpha. Okay, the next point is alpha radiation. We study one by one. So first we start alpha radiation, then beta radiation, then gamma radiation. Okay, first we start alpha radiation. So what's alpha? Alpha is a positively charged particle. Alpha is a positively charged particle from the nucleus of an atom, from the nucleus of an unstable atom. For example, this is an unstable nuclei, or this is a nuclei of unstable atom. So this atom, to become a stable or to close the stability, it releases a radiation. Okay, usually alpha particle is released when the number of protons is greater than the number of neutrons. When the number of protons in the nucleus increase, their repulsion force increase. So some of the particles in the nucleus is reduced to close the stability or to become that atom stable. Okay, for example, when 2 protons and 2 neutrons is released, that particle is called alpha. That particle is called alpha. So alpha has 2 protons and also 2 neutrons. 2 protons and 2 neutrons. So okay, alpha contains 2 protons and 2 neutrons. Alpha usually is produced when the number of protons greater than the number of neutrons, okay. Properties of alpha particle. So alpha particle is a positively charged particle. It's a positively charged particle. It means it has a +2. It means it has +2. Okay, it is a helium nucleus. Okay, what it means? Okay, for example, this is a helium. So helium has a 2 protons and 2 neutrons in the nucleus. 2 protons and 2 neutrons in the nucleus, and outer shell have 2 electrons. And it has 2 electrons. So the nucleus of a helium, not helium. The nucleus of helium. Okay, 2 protons and 2 neutrons. The nucleus of this helium is called alpha. So alpha is a nucleus of helium and can be donated as alpha. 2 protons with, and also it has 4 mass number. Okay, or can be donated as helium. So helium has 2 protons and also 4, and I have a mass number of 4. Okay, so alpha is a helium nucleus. Okay, alpha travels 5% of speed of light. It travels 5% of speed of light. Okay, it has high power of ionization of air molecules. When it travels through the air, it removes the electrons in the air. So the air becomes positively charged particles because it removes the electrons from the air. Okay, alpha particles have a low penetrating power. So the alpha particles have a low power of penetration. And can be stopped by the outer skin and also thin sheets. Okay, this means it travels few centimeters in air. Okay, alpha can be detected device called detectors of photographic film. And also can be detected closed chamber. Okay, we study the next topic, the detectors. The next topic is the detectors of radiation. Okay, examples of alpha are, so alpha usually emitted by the atoms with greater atomic number. For example, radium, uranium, thorium, and also good laboratory source of alpha radiation is americium 241. It's americium 241. So americium is used source of alpha in laboratory. Used source of alpha in laboratory. Okay, nuclear equation. What's a nuclear equation? Okay, what's a nuclear equation? So nuclear equation, we have this is a stable atom. This is a stable nuclei. This is a stable nuclei. Okay, when this stable nuclei bombarded into neutron, that stable nucleus become unstable and it releases a radiation. Okay, and it releases a radiation. Okay, so the reaction in the nucleus, the reaction occurring in the nucleus is called nuclear reaction. The reaction in the nucleus occurring in the nucleus is called nuclear reaction. And also the equation that represents the reaction in the nucleus is called nuclear equation. It's called a nuclear equation. For example, so nuclear equation connects the mass of the reactants and the mass of the products, and also it connects the atomic number of the reactants and the atomic number of products. Okay, and nuclear equation, we take the sum of the mass number of the reactants. The sum of the mass number of the reactants. The sum of the mass number of reactants is equal to sum of the mass number of the products. Okay, the sum of the protons of the reactants is equal to sum of the protons of products. So we see the example. Okay, example. When the neutron is bombarded into nitrogen atom with carbon carbon 14 and other nuclear result, identify the unknown element. So for example, we have a nitrogen. That nitrogen is bombarded into a neutron. Okay, it produces a new element called carbon 14, and also new element is X, and new element is X. Okay, so firstly, the sum of the mass number of the reactants is equal to the sum of the mass number of the product. Is equal to sum. So now we have okay, we have nitrogen. Okay, we have nitrogen 714 plus neutron. Okay, is equal to carbon 14 6 carbon 14 plus unknown element with mass number A and atomic number Z. Okay, so the sum of the mass number of reactants, so 14 plus 1, the sum of the mass number of the reactants is equal to the sum of the mass number of the product, 14 plus A. So 14 is equal to 15 is equal to 14 plus A. Import this side 14 minus 15 minus 14 is equal to A. Therefore A is equal to 1. Therefore mass number is equal to 1. Okay, we find the atomic number. So the sum of the atomic number of the reactant is equal to the sum of the atomic number of the product. So 7 plus 0 is equal to 6 plus Z is equal to 6 plus Z. So 7 plus 0 is 7 is equal to 6 plus Z. So import this side the 6, so 6 equal to Z. So subtract. So 1 is equal to Z. Therefore we have a new element with mass number 1 and also atomic number 1. That element is hydrogen. That element is hydrogen.